Okay, we're going to start with lesson 7.7, simple and compound interest. Interest is the amount of money paid or earned for the use of money by a bank or other financial institution. Simple interest is paid only on the initial principal of a savings account or loan. To solve problems involving simple interest, use the following formula. And the formula says interest is equal to principal times rate times time. And in this box, there's some things to be aware of about this formula. First of all, P, the word principal, is just talking about the amount invested or borrowed. The R rate is the annual interest rate, and it's always expressed as a decimal. And then T is the time, always in years. It's always the number of years the money has been invested. So let's see how this works in an actual example. So example 1, find the simple interest to the nearest cent. $2,000 invested at 2.5% for 3 years. Okay, when using the simple interest formula, it's helpful to first determine which part of the formula you're trying to find. So for these two examples, it says find the simple interest. So we're looking for the I, the amount of the interest. So let's identify the other parts in this question. $2,000 invested. That sounds like that's the principal. That's the amount invested. So this is P. 2.5%. That is a percent. So if I change that to a decimal, that will give us the annual interest rate. And T is the time in years. 3 years is T. So now we should be able to just put this in the formula and punch some numbers in the calculator, and we will be able to calculate the total interest. So I equals PRT. We're looking for I. P is 2,000. R is 2.5% as a decimal, so move the decimal back 2 places to get 0.025. And T is 3. And when we multiply 2,000 times 0.025 times 3, we will get $150. Alright, let's do the same thing for B. Again, we're finding the simple interest, so we're looking for I. $4,500 invested is the P, the principal. 4.25% is the rate. And 2 years is the time. Alright, so our formula, I equals P, R, T. We're looking for I. P is 4,500. R is 4.25%. And we'll move the decimal back 2 places. 0.0425. And T is 2. And when we multiply those 3 numbers, we get a total amount of interest of $382.50. Alright, let's look at an example that's a little more complicated. Example 2 says Mr. Webster borrowed $1,280 to buy a new swimming pool. He will pay $57.60 each month for the next 24 months. Find the simple interest rate for his loan. Well, just like in the first example, we want to first identify which part of the formula we're looking for. Well, this asks us to find the simple interest rate. So we're actually trying to find R this time. So let's identify the other parts from the problem. Mr. Webster borrowed $1,280. So this is the amount borrowed. That is the principal, P. He will pay $57.60 each month. Well, this doesn't really fit into our formula anywhere. So let's hold on to that for a minute and come back to it. The next 24 months. This sounds a lot like time, but it's not in years. So we'll label this as T, but we have to remember later that we really want this to be 2 years, not 24 months. Okay, so I see P, R, and T. What I'm missing is the interest. And since that's not what we're looking for, we should be able to find it somewhere. Well, the interest is just the amount extra that he pays to take out this loan. If we know how much he pays and for how long, we know that we can find the total amount that he pays. And whatever the difference is between that and what he borrows, that would have to be the interest. So let's start off by finding that. So if he's paying $57.60 a month for 24 months, we can multiply those to get the total amount that he'll pay, which is $1,382.40. And then again, the difference between this amount and the amount that he borrowed is the interest. So he's paying a small amount of this interest every month. So we'll find the difference between these two to get what the I in our formula will be. When we subtract those, we get the interest is 102.40. So in our formula, this number is I. Okay, now we can use the formula. I equals PRT. Well, I is 102.40. P is 1280. R is what we're looking for. And T is 24 months. Remember, we want that as years, so that would be 2. Alright, and we will just solve this just like a regular equation. So this is 102.40. We'll multiply those two numbers to get 2560. Don't forget the R. And then to get the R by itself, we will divide both sides by 2560. So we'll get the R is 0.04. And remember, what we're finding here is the rate as a decimal. So a better answer here would be to change this to a percent and say that the rate is 4%. Okay. On the bottom half of the page are some try-it-yourself problems for you to do on your own. Do not forget to show your work on these. You should have the formula written down and the numbers substituted in correct places, followed by calculation, which of course you can do on the calculator. So pause the video, work through these problems. When you're ready to check your answers, go ahead and hit play to resume. For the first one, you should have gotten $540. For the second one, $170. And for the last one, 4%. Okay, let's go to the next page and talk about compound interest. Compound interest is paid on the initial principal and on interest earned in the past. So this is usually how interest is calculated in the real world. What this means, basically, to give you a very simple example, let's say you were to invest $100. Under simple interest, let's say your interest rate is 5%. Make it nice and simple. Under simple interest, at the end of the first year, you would have the $100 you invested plus 5% of that $100, or $5. So your balance would be $105. At the end of the second year, though, the interest is still calculated on the $100 that you invested. So you're really only earning $5 each year for however many years you leave this money invested. The amount that you earn in interest never goes up. Under compound interest, though, at the end of the first year, you'd still have $100 plus the $5 in interest. But then when the interest is calculated the following year, you're calculating interest on $105, not on just the $100. So you're earning interest upon interest. And compound interest can be a beautiful thing when it's working for you, in the case of investments, but it can be a very, very bad thing when it's working against you, in the case of money that you've borrowed for example, a loan to pay for a car, or really, really bad credit cards. The interest rates on those can be really high. And again, that's compound interest. You're paying interest on the interest that you've already been charged. So Compound interest is great when it's working in your favor, not so great when it works against you as far as money that you owe. But anyhow, let's focus on how to calculate compound interest. So you have two options. You can use the simple interest formula once for each year. And if we're only talking about 2 or 3 years, this isn't that bad, but I'm sure you can imagine having to calculate the simple interest once for each year. If, say, we were talking about 10 years or 12 years, that can easily turn into a lot of work. Or you can use the following compound interest formula. And this is not in your textbook in this section, but it is a formula that you will see again later on in other math classes, so it's good to at least be aware of this formula. It looks really complicated, and it's actually not. So let's look at each of the parts of this formula. In this case, A is the amount after n years. That's the total balance, including interest. So you're not just finding the amount of the interest here, you're finding the total amount. The P, just like in simple interest, is the principal, the amount invested or borrowed. And then in parentheses, you have 1 plus R, just like in simple interest, is the annual interest rate as a decimal, divided by N, and this is the number of times interest is compounded per year. So then, if your interest is compounded annually, that would be 1 time per year, so N would be 1. If the interest is compounded monthly, though, there's 12 months in a year, so N would be 12. Most of what we will deal with for now will be cases where N is 1, which makes this very, very easy to calculate. And in this exponent up here, we have N, same N as down here, and then T, which again, just like in simple interest, is the time in years. And I will show you both ways to calculate compound interest. Let's go ahead and look at example 3. Example 3 says, what is the total amount of money in an account where $800 is invested at an interest rate of 6.25% compounded annually for 2 years? And we'll look at 2 ways to do this. So, method 1, let's use the simple interest formula. Once for the first year and once for the second. So, for year 1, we have our simple interest formula. Interest equals principal times rate times time. And we don't know what the interest is. The principal, the amount invested, is $800. The rate as a decimal, 6.25%, so as a decimal, 0.0625. And the time, be careful here, because we're talking about compound interest, we don't want to put 2, because we want to split this into 2 separate years. And because compound interest, we're going to earn interest on whatever interest is earned in year 1. So this will just be 1 year for now. And when we multiply these, we find out that the interest earned at the end of the first year is $50. Well, that amount will be added to the original amount invested. So we invested $800 and earned $50 in interest. So going into the second year, we have $850. So let's look at what happens in year 2. In year 2, we're still going to use the same formula. At the start of year 2 now, though, we're investing $850. Now the rate is still the same. And again, we're only talking about 1 year at a time. So now when we multiply these, we get, rounded to the nearest cent, $53.13. So notice here that the interest in the second year is more than the interest in the first year, because you're earning interest on this $50 of interest, not just on the $800. So that's what makes that earn more money. So now if we want the total, at the end of year 1 we had $850, and then during year 2 earned $53.13 in interest, for a total of $903.13. Okay, so that is one method that will work to calculate compound interest. Let's look at another method. This method will use the compound interest formula, which is this formula again that's at the top of this page. So we have A equals T times 1 plus R over N to the NT. Alright, and let's fill in the numbers we have. A is what we're looking for, that's the total amount. P is the principal, $800. And then 1 plus R is the rate as a decimal, so that's 0.0625. N is the number of times interest is compounded per year. And in this problem it says compounded annually, so that's once per year, so N is 1. And then up here, N is still 1, times T, the amount of time is 2 years, so times 2. Alright, now this looks really ugly, but we're going to simplify it to make it look much, much better. So we have 800, and then in the parentheses, the second set of parentheses, let's look at this really closely. 0.0625 divided by 1. We don't need this 1 here now. We can just say that this is 0.0625. And when we add 1 plus 0.0625, it just comes out to 1.0625. And in the exponent, 1 times 2, of course, is just 2. Okay, now because we don't want to have to round off a lot in the middle of the calculation, you're going to want to do this in your calculator pretty much all at once. There's a couple ways you can put this in. On your calculator, there actually is a button that will do squared. So if you type this part in just the way you see it, with the parentheses here and the squared at the end, it should give you the same amount that we got with our first method, 903.13. If you do it in separate steps, you can do 1.0625, and then squared just means 1.0625 times 1.0625. And you get a very long decimal, but just go straight from that to multiply that by 800. So that you're doing this thing squared, because that's an exponent, it has to come first. This thing squared times 800. And if you put that in the calculator correctly, you should get the exact same answer we got before. Rounded to the nearest cent is 903.13. Just like we got with method 1. So you can use either of these methods. Again, just be aware that the compound interest formula will show up again later on in math classes. And this is really not that much more difficult when the n is 1, when it's only being compounded annually. But you won't be able to use the simple interest formula when you get to more complex problems later where interest is compounded more frequently than that. Okay, so go ahead and try your hand at some compound interest on your own. Again, you can use either method, whether you want to use the simple interest method or the compound interest method. But for the try it yourself problem, make sure that you show your work and pause the video when you're ready to check your answer. Go ahead and hit play to check your answer. Alright, and for this problem, the total amount after 3 years should be $5,788.13. Okay, let's shift gears quite a bit and move on to talking about circle graphs. A circle graph can be used to compare parts of a data set to the whole set of data. The percents in a circle graph add up to 100% since the entire circle represents the whole set. In order to create a circle graph, you will need a compass and a protractor. So for this portion of this lesson that we're doing in this video, we're not going to actually create a circle graph simply because of just the difficulty of giving directions on a video of how to create a circle graph with a compass and a protractor. So what we're going to do is just talk about how that will be done, and then in class tomorrow we'll go ahead and create those circle graphs together. So What that means is that you need to make sure that you bring a compass and a protractor, or at the very least, a protractor to class with you on Wednesday. Okay, so when you're creating a circle graph, in example 1, for example, we're starting with the percentages represented by each of these parts. Well, if you're going to create an accurate circle graph, we need a bigger portion of the circle to be represented by the pizza, and obviously a much smaller portion of the circle represented by other. And we want it to be proportionate so that, for example, hamburger is 6 times the size of other, because 3 times 6 is 18. So we want this scaled correctly. Well, these percents they all add up to 100, and the whole circle, the central angles in the circle will all add up to 360 degrees. So the central angles for each portion of the circle graph will be some percent of 360 degrees. So all we're going to do for now is figure out how many degrees will be in each section. So here the pizza is 42% of 360, or if we change that to a decimal, 0.42 times 360. And that comes out to 151.2 degrees. Let's do the same thing for tacos. 5% or 0.05 of 360, and that is 18 degrees. For hamburger, 0.18 times 360 is 64.8 degrees. And then chicken nuggets, 0.23 times 360 is 82.8 degrees. And spaghetti, 0.09 times 360 equals 32.4 degrees. Oops, not percent, degrees. Alright, and the last one, other 3% of 360, so 0.03 times 360. Comes out to 10.8 degrees. Okay. And if you wanted to double check these, if you added up all of these numbers, they should add up to 360 degrees. And what we'll do in class tomorrow is actually create, in this space over here, we'll create a circle graph, and we'll measure the angles from the center so that they actually come out to, now probably not this precise, but an approximate number of degrees that matches this pretty closely, so that the pieces of the circle graph will correctly represent this set of data. So for now, this is all we want, is the number of degrees in each section. Okay. For an example like number 2, notice here that you're not given the percents. So that would be the first thing that you would need to calculate. And in order to calculate a percent, we would need to know what the whole is. So let's figure out what the total is here. 2 plus 3 plus 8 plus 4 plus 7. The total is 24. So we first want to figure out what each of these is as a percent, and then we can figure out what the corresponding central angles would be in the circle graph. So for each of these, to calculate a percent, remember we want the part over the whole. So this will be 2 over 24. And when we divide this and change it to a percent, we get this is 8.3 repeating percent. Homework is 3 over 24. And again, when we divide, change that to a percent, this is 12.5%. Sleeping is 8 over 24. When we divide that and change it to a percent, that's 33.3 repeating percent. And then recreation is 4 over 24. And when we divide those, change it to a percent, that's 16.6 repeating percent. And then school is 7 over 24. which if we divide those, yep, and then change it to a decimal, that is 29.16 repeating percent. Okay, now we have the same information that we had in the table in example 1. We have the percent that corresponds to each of the sections. That's exactly what we found here, the percents that correspond to each of these sections. So now we'll take our percents and multiply by 360 to get the measure of the central angles in the circle graph. And for the first one, we end up with 30 degrees. For the second one, this is 45 degrees. For the third one, 120 degrees. For recreation, this is 60 degrees. And school is 105 degrees. Okay. And again, in class, we'll go ahead and use our protractors to create an accurate circle graph to represent this data. But for right now, that is all we're looking for, is the measures of the central angles. Okay, on the next page, we have a couple try-it-yourself problems. And again, remember, all you're looking for right now is the measure of the central angles for each of these. So go ahead and pause the video and work through the 2 try-it-yourself problems. And when you're ready to check your answers, go ahead and hit play to resume. Okay, your central angle measures for the first one, for cheese, will be 122.4 degrees. For pepperoni, 100.8 degrees. For mushrooms, 75.6 degrees. And for other, 61.2 degrees. For the second set, radio is 154.8 degrees. Friends will be 108 degrees. Television is 57.6 degrees. Parents is 25.2 degrees. And other is 14.4 degrees. Okay, so aside from actually just constructing circle graphs, there are other things that we can actually do with circle graphs. So we'll look at that on the very last page. So when you know the percentages that make up each of the portions of a circle graph, you can use that to find an actual number that corresponds to any of those sections, as long as you know either the total amount represented or even just a portion of the total amount represented by a given slice of the circle graph. So let's see how that works. So example 3 says the circle graph shows the results of a survey about favorite pets. If 800 people were surveyed, how many people prefer dogs to cats? Okay, so the section of this circle graph that we're looking for is this section that says 36% prefer dogs, and this section that says 28% prefer cats. Okay, but we don't want to know the difference in the percentages. We want to know how many people, so the difference in the actual numbers. So let's see how many people actually prefer dogs. It's 36% of the total, 800. Remember, the part is the percent times the whole. So in order to find that, we want 36% of 800, or just 0.36 times 800, which is equal to 288. Let's do the same thing to find out how many people prefer cats. So cats are 28%, of the same amount, 800 people. So we'll change 28% to a decimal. And when we multiply those, we get 224 people. Okay, and the question asks, how many people prefer dogs to cats? So this is just asking about the difference between those two numbers. So we take 288 minus 224, we get 64. So this is 64 people that prefer dogs to cats. Alright, so on the try it yourself problem, you're going to do something fairly similar. Make sure you are looking at the correct portions of this circle graph. And go ahead and pause the video, work through this, and when you're ready to check your answer, go ahead and hit play to resume. Okay. And for this one, we're talking about billions of dollars. So when you did your calculation, you probably came up with 0.6 billion. But we never write numbers like this. So if it's less than 1, we actually want to change this to million by moving the decimal over 3 places. So this would be $600 million, of course. So if you had 0.6 billion, you were on the right track. We just need to change that to 600 million so that it's written properly. Okay, and that is it for circle graphs.